So using the table of value, in this case, they gave you the x values. They gave you the function, so it's 3 to the power of x. Right, what can you tell me about this function? What kind of function is it? It's exponential, right? But we're going to have to prove it using the table of value. Okay? So 3 to the power of x, that means it's 3 to the power of
negative 2.
negative 2. Now, remember, I don't like fractions.
1 over
1 over 3
1 over 3
to the power of 2. That's right. So 1 over 3 to the power of 2. So that's 1 over 9. Okay? And you're going to have to leave it in this form. 1 over 9.
1 over 9?
Yes. It's a fraction. Right? 1 over 9 is not 0.1. It's blah, 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 blah. Right? It's what is it? Yes, it's 0.11111, and it's not 0.1. Okay? How about 3 to the power of negative 1?
It's 1 over 3.
1 over 3.
Oh, yeah.
To the power of 1, which is 1 over 3.
Yeah.
Very proud of you guys. Okay, how about 3 to the power of 0?
1.
1.
Yes. 3 to the power of 1?
3.
3 to the power of 2?
9.
So I'm going to write the y values here. So 1 over 9, 1 over 3, 1, 3, 9. Good. Now to do the first ratio, that means I have to divide 1 over 3 by 1 over 9. When you enter this on the calculator, make sure you enter it in brackets. Okay? So to do this, I'm going to write it right here. So you're going to do 1 over 3 divided by 1 over 9 in brackets.
Like individually in brackets or the whole thing?
So you do bracket 1, so this is how you can enter it on the calculator. Bracket 1 divided by 3, close bracket, divided by, open another bracket, 1 divided by 9, close bracket, hit equal. What do you get?
I got the same answer either way with those brackets, but I got 3.
But because you have a fraction form, right? Other calculators don't. Yeah.
3.
3.
3.
Yeah. The answer is 3. Now do 1 divided by 1 over 3. What do you get? Do this divided by this.
Oh, 1 over, okay.
1 divided by 1 over 3.
3. Somehow they're gonna be the same.
3 divided by 1?
3.
3 divided by 1 is 3. 9 divided by 3 is 3. Your first ratio is constant. Eyes on the board for a second. You see how your first ratio is 3? What was your base?
3.
I told you, right? I told you that whatever your first base is, whatever your first ratio is, it's going to be your base. Right?
That's called,
If it's exponential, obviously.
that's called magic number.
Okay. Tell me what is the second table of values? What's the second function? What's your function?
1 over 2.
1 over 2
X.
to the power of x. Right?
Okay, and the power.
That's a half to the power of x.
Okay.
Okay? What kind of function is it? Looking at it. Exponential. Because your exponent is a variable. Right? Okay. We know that. What's our base?
1 1.
What a half, right? My base is a half. So I'm expecting that my first ratio is going to be half. Okay? I already know the answer. I just have to prove it. Okay? So a half to the power of -2. Don't do it on a calculator. What do you have to do if you have a negative exponent?
Just
Flip.
flip
What
it.
does it become?
2 over 1 equals to, sorry, by power of 2.
2 to the power of 2, which is
4.
4. Right? If I flip this, it will be 2 over 1, which is 2.
Okay.
2 to the power of 2 is 4. Right? How about a half to the power of -1?
Same thing. 2 over 1.
2 over 1 to the power of
1.
1.
Gonna be
2
2.
to the power of 1, which is
2.
2. How about half to the power of 0?
1.
1. How about half to the power of 1?
2.
I.
Why 2 over 1 to the power of 1, 2? That's not the same.
A half to the power of 1.
Oh,
It's
yeah,
a
yeah.
half.
No negative. Sorry. It's a half, yeah.
How about half to the power of 2?
It's 1. It's 1? No. No.
Isn't it 1/2 times 1/2?
Which is?
1.
No.
How is
1
1/2 times
3.
1/2?
3. Is it 3?
What?
I'm confusing myself.
That's when you're adding, not when you're multiplying. 1 over 4.
So, which is 0.5.
Don't go to decimals, please.
I'm so confused.
Don't turn Kevin now.
0.5 times 0.5 is 0.25.
Yes, you're multiplying, you're not adding. If you're adding a half and a half, it makes a whole. But if you're multiplying a half by a half, it makes a 0.25. It makes a quarter. Welcome to math.
See this picture over there? That moment in when you understand family. That's exactly us.
Okay,
Dude, I feel like there should be a bigger number.
no, because you're multiplying a decimal by a like a number less than 0. A number less than 1, between 0 and 1, by itself, it gives you a smaller number. Trust me. Okay, now my first ratio, so I have to do 2 over 4. What's 2 divided by 4? 1 over 2. Right? Remember, I told you, it's going to be the same. How about if I do 1 divided by 2? 1 over 2. How about if I do a half divided by 1? Half. How about if I do a quarter, so you can do that on the calculator, divided by a half.
Two?
No, quarter divided by half is a half.
You put 1. You put 1. Yeah. 4.
Okay?
Okay, alright, I figured it. Alright.
So, again, this is an exponential, right? And it's an exponential because the first ratio is constant. And I already told you, before we even did this table, that your first ratio is going to be a half.
So what do you mean that?
What?
I want to show you, right? I know.
See what I show my work.
Can I just skip to the next question and I'll come back to this? I just want to end the video because, yeah? I'll come back to this. So, examine each graph, determine the type of relation that it presents, give a reason for your answer. What's the first one?
Quadratic.
Quadratic. Why?
First problem.
the second one? Exponential. Can you tell me if it's growth or decay?
Right.
Yeah,
You said DT.
it's a growth. Because as you go from the negative to the positive,
You said
it's growth,
Oh.
right? You always move from the left to the right. You always move this way, right? What's happening to my graph? It's going up,
So,
right?
how will we know if it's PK?
It will look like this,
Oh, okay.
okay? And flat on one side and then growth on the other.
PK?
No.
No, but that's zero.
It will not, in this case, no, in most of our cases, it will not be